Hello, welcome to everyone in this video. This is the part 2 of measurement, that is the physics of microwave. Actually, we uh, cover up the advanced paper of M.Sc 4th semester, that is the microwave, and we already cover up this portion, that is the transmission line and waveguide and component, already cover up in the previous lectures. And in the last lecture we actually discuss about the measurement part of this microwave, that is mixture, single stub and double stub matching. This portion we already covered in the last lecture, right? In this lecture we want to discuss this portion, that is the microwave bridge, measurement of frequency, attenuation and phase. This portion we want to cover up in this lecture, right? So you can watch this the total syllabus of this microwave, that is transmission line and waveguide, component, then measurement, then source, then antenna, and finally microwave integrated circuit. So this is the total syllabus we wants to cover up by the day by day lecture, right? So this is your recommended books. Actually I referred to this book for this lecture. So you can refer to these books, and there are the lots of books you can refer this also, right? So let's start today's discussion, that is the microwave bridge. Bridge means there's a connector. Bridge is nothing but like a connector, you can say. You can say this as a connector, and this will be actually used for phase and attenuation measurement of the microwave, right? So this is a measurement of this is the instrument to which actually used to measurement the phase and attenuation, right? So microwave bridge can be measured the phase and attenuation partially in the plasma, particularly in the plasma diagnostic. So you remember the actual use of the microwave in the plasma generation to develop the electronic devices, and for plasma diagnostic, this meter, that is the microwave bridge meter, actually used to measure the phase and the attenuation, right? And this meter bridge actually there are two types, that is transmission bridge and the reflection bridge. There will be two type microwave bridge available. First one is micro transmission bridge, second one is reflection bridge. And go to the first one, that is the transmission bridge. You can see the schematic diagram. That is the source, that is the microwave source, and this connected with this T is divided into portion. The passes through sample, and next is passes through attenuator and the phase shifter, and they are combined to reach the detector, or you can say this is a power meter. This is a detector, or you can say this is a power meter. It can measure the power of this microwave, right? So you can see here there are two T connector, are this is actual bridge connector. This two T connector are used to here, and the at the first initially we does not place this sample. These are sorted, these are connected, and these are microwave goes through this path, and this through this path through the attenuator and phase shifter, and reaches to this detector, and we adjust this attenuator and the phase shifter such that the power meter gives null value, right? So we adjust the attenuator and phase shifter without this sample, this power meter as 0. Now we place the sample, then what happen, there will be change of the power meter, and we again we adjust this attenuation and phase shifter to become a power meter, to become 0 of the power meter. So the there is two there is a change of attenuation before and after placing the sample, right? So there is a change to what amount will be what amount of change of attenuator and the phase shifter we need to become this power 0 after placing the sample is the value of the attenuator and the phase shifter of the sample. I think clear how we can measure the attenuation and the phase of the microwave through this transmission bridge, right? So go to the next, that is the reflection bridge. You can see this is the schematic diagram. this is a reflector. Reflector means a metallic surface, and they are also a reflector. This is a metallic surface, and this is a microwave source. This goes through a magic tree. You know the magic tree. Previous lecture, in the previous lecture we discussed deeply about the magic tree in the component part of this microwave. So you can refer to this lecture to understand the characteristics of the magic tree. Okay, there is a forearm. You can see there is a this is actually combination of ET and the HT, electric field tree and the magnetic field tree, right? So this is a combination of electric field tree and magnetic field tree called a magic tree, and these are the forearm. You can see here this sum, that, and so one arm is connected with source, and another two arm connected with the sample and the attenuator, and other arm is connected with the detector. Clear? With the detector, connected with the detector. Clear? So you can see here, when the microwave comes from the source, so microwave source is go to this towards sample and attenuator, not towards detector, because you know about the S matrix, symmetric matrix. If we in from this three number, port number 3, then it goes to 1 and 2. So this comes to the source. By the source it go to the reflector and come back from the source again, and it's also and the other part goes to attenuator and phase shifter and reflected, and then phase shifter and attenuator comes here. So when they are enter from these two side, 1 and 2, then it's emit from the fourth side. You remember the magic tree characteristics. So finally what happened, the microwave comes from the source, go to these two side, and then after reflected they comes and go towards the detector. So we get the value of the phase shift and attenuation value of this sample. Clear? So there is two method to find out the attenuation and phase shift of a sample. First one is the transmission bridge, and second one is the reflection bridge. Clear? So now comes into the next point, that is the how we can measure the frequency of the microwave. There is two actually four process. First one is the direct method. In the direct method there is two process, cavity method and the electronics method, and another one is the indirect method. In the indirect method there is also two method. First one is the lambda g. Lambda g, you know the wavelength of the guide wavelength, you can see, and the VSWR, that is the voltage standing wave ratio. By to this method, this is our indirect method. By to this method we can also find out the frequency of the microwave, right? So let's discuss about the four method, how we can find out the frequency of the microwave. First one is the cavity method. In the cavity method you can see this schematic diagram of this is a waveguide, and here this power meter. This is a power meter. Within that there is placed a cavity. This cavity will be cylindrical or the rectangular. This is actually cross sectional view. So this is a cylindrical, and if you put the rectangular, this cross sectional view will be like that. This cross sectional will, sorry, this cross sectional view will be like that. Clear? So here you can see there is a this is a method by this is a direct method to find out the frequency, and the meter like a cylindrical cavity. This meter actually cylindrical cavity, radius of the cavity a, which is fixed, and the length of the cavity, this is a side view of this cavity. You can see this length of this cavity actually changed by placing this by adjusting this metallic surface. Okay, so after changing this metallic surface you can change the length of this cavity. This is front side and this is back side. So this reflector changes such that the resonance actually occur. So you can see here again the length of the cavity adjusts to match the frequency. That means the frequency of the microwave and this the cavity structure are matched such that they are produced a resonance, right? So when the resonance occurred, then the power meter detector gives 0, because the when the resonance occurred, then the total power is matched with this cavity, that is the energy, total energy trapped within this cavity. So we did not get any power in this meter. Okay, so when we get zero power in this meter, then you can say they are actually resonance happening. After getting the resonance, then you can find out the frequency using this formula of the dimension of this cavity, either cylindrical or the rectangular. Clear about these things. So the microwave comes towards the power meter, and they are connected a cavity, either cylindrical or rectangular. Then after adjusting this metallic plate or a reflector such that the total power will be 0. How we can see this total power will be 0? In this meter we can see this, the total power is 0. That means the power does not reaches to this meter. Then what happens? This total power is trapped or the resonance or the matched with this cavity. That means the frequency of these two, that is the actually matched towards the incident microwave. So after from this formula for the cylindrical or the rectangular, we can find out the frequency from this dimension where the power meter gives 0 value. Clear? So this is the cavity method by which we can directly find out the frequency of this microwave by measuring this dimension of the cavity at the resonance condition. The resonance condition means the power will be 0 at the power meter. Next one is the frequency counter. Now this is another meter direct measurement method to find out the frequency of the microwave, is the frequency counter. So if you input the microwave at this point, this comparator here, and this is source signal, and this is beat counter, and this is analyzer, this is electronic circuit. What happened if we incident a frequency, microwave frequency with frequency f, and then okay, so the frequency of incident microwave wave is f, and there are two resonance that is n f1 equals to f, and then the successive, and this will be n minus 1 f2 will be also f, right? So from this first mathematics you can see here this f equals to f by f1 equals to n, and f by f2 equals to n minus 1. After minus these two things, you will be finally get this one, and this f equals to f1 f2 by f2 minus f1. So we actually find out the f1 and f2 at which this resonance happening, two successive resonance actually happening. After the finding the f1 and f2, we can find out the frequency of this microwave. Input frequency means actually frequency of microwave, because we discussed about the microwave, actually we input the microwave, right? Microwave frequency. Clear? Though, so these two are the direct method by which we can find out the frequency of this microwave. Next, go to the indirect method. First one is the Lambda G method. Lambda G means the waveguide wavelength of the guide method. Here you can see this is a waveguide, and you know within the waveguide the microwave behaves as standing wave. So the wave is like that, and this is a null detector which can detect where the power is 0. So this is a null detector. We displaced this in this direction and find out the position where the power is 0. So at first we get the power will be 0 at that point. We measure the using scale at this point, and if we place towards the right hand side, and then the next null 0 point we will find out at point B. So after point A, we get the null point at point A, and after that the next null point will give find out at point B. So then we can measure this distance, we can measure this length using any scale. So this length is nothing by lambda g by 2. This length is nothing but the lambda g by 2, right? Wavelength by 2. So this length will be lambda g by 2. So lambda g is nothing but twice L. Then we can find out, because we know the lambda g related with lambda, you know this relation from the transmission line expression. You can go through this, you will be get at very beginning first chapter, I think. This relation in the first chapter you can get this lambda g, that is the wavelength of the guide, is nothing but the wavelength of this microwave. Lambda is the wavelength of microwave. Lambda is the wavelength of microwave. Lambda is the wavelength of microwave. This is wave length of microwave. This is wavelength of microwave, and lambda g is nothing but the wavelength of guide. These are related by this relation, you know these things. So if you put the value of lambda, which is c by f, and if you introduce c, this will be f square minus fc square. Fc is the critical frequency. So putting the value of lambda g, which is 2l, lambda g is twice l, and square this in the upper side, and squaring will be get the resolution. Finally we get the frequency of this of this microwave. So the frequency of the microwave, you can see this c is the speed of light. This c is nothing but the speed of light in free space. Speed of light in free space. See, c is the nothing, the speed of light, speed of light in free space, right? So speed of the light on the free space is the c. So c, you know the length is can be l can be find out using this null detector, the length between two successive null point, and fc will be cutoff frequency, which also find out from this formula. So after getting this, say you will be get the frequency of this microwave. Since we does not measure the frequency of this microwave, we measure actually length. That's why this is called indirect method. We did not find out the frequency directly. We find out directly length and then calculate the frequency using this formula. Clear? I think clear about the indirect method, lambda g method, to find out the frequency of the incident microwave. Next one is the VSWR method, voltage standing wave ratio. You know this will represented by rho. This will represented, sorry, this will represented by rho. This is rho. So this is P max by P min, or you can say this is root under P max by P min, because P equal to V square by R. So after changing this detector, this probe, you can find out the maximum power P max, and you can also find out the minimum power. After getting maximum power and minimum power, you will be get the you will be find out the value of rho, the standing wave ratio, right? So this is a waveguide, and this wave are standing wave are within this waveguide. This is actually a standing wave, you know. Within the waveguide, the microwave will be standing wave, because the forward wave and the reflected wave are placed in the same position, because this forward wave and this reverse wave are incident at the same position at a time, then it produce the standing wave. And within the microwave, the within the waveguide, the microwave are in the standing wave. So within the standing wave, you can find out the maximum power and the minimum power. Then we get the value of rho using this formula, and after that you will be get the reflection coefficient. You know this relation we just discussed in the last lecture about this relation, reflection coefficient. And from this Smith chart, which already already we discussed, Smith chart chart actually this is not charge, Smith chart. Smith chart. Using Smith chart, we can obtain the value of this frequency. So this is also an indirect method because we measure the power, not frequency. From the power we calculate the frequency. That's why this is called indirect method. So in this method we measure the power, we measure this power, measure power, right? And in this method we measure the length, we measure length, not frequency, measure length. That's why these are called indirect method. But in the previous two cases we directly measured the directly measure the frequency of the microwave, the frequency of the microwave, of the microwave, of the microwave, of the microwave. Clear? So in direct method we directly measure the microwave in the cavity using cavity, and there is a frequency counter. And indirect method does not measure frequency directly, does not measure frequency directly. So indirect method, this does not measure frequency directly, but whereas in direct method we measure the frequency directly. And in the lambda g method we measure length and then convert it into the frequency, and whereas VSWR method we measure the power, then convert it into reflection, reflection coefficient, and finally we find out the frequency. So I think clear about all this. If there is any doubt, you feel free to contact with me, and also you can comment in the comment box. This is all about me, and this is my contact details, and this is my YouTube channel details. Go to this channel, you will get the others video with this related to the physics. And if you get anything new or benefited from this video, you can like this session, share this video to your friends, or she or he also get benefit from this video. Subscribe this channel if you new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get the notification of upcoming video. So take care, we will meet in the next video as soon as possible. Thank you.